Okay, dear student, ठीक है. So this is a revision session on one-dimensional motion. Okay. So previously we studied that. A second. Okay. Yeah. So previously we saw that in the study of kinematics we have speed. Right. These are some keywords. Okay. Let me just go down. Right. So we have speed, we have velocity, we have displacement, and we have distance. Okay, we saw what the difference between velocity and speed is, and displacement and distance is. We saw a diagram that looks something like this, right? So this was displacement from the starting point to the end point, and the distance was the path which was traveled, the actual path traveled. Okay, so we saw a couple of these things, we did some examples, and better than we saw that what is uniform and non-uniform motion. We also saw what is acceleration. Acceleration is rate of change of velocity, right? Rate of change of velocity. Okay, and then we saw that there are two types of acceleration: uniform and non-uniform. Uniform mean every second the velocity is increasing by the same amount. So here it is increasing by 10. So every second it is increasing by 10, the velocity. Okay. So in non-uniform motion, the velocity is going to increase by different amounts. For example, it increases by 10, that it increases by 20, right? And so here it is increasing by 10, but for non-uniform it's going to increase by 10, increase by 20, increase by 50, increase by 60, and the velocity can also decrease every second. When the velocity decreases every second, right? When the velocity v decreases every second, we say that is negative acceleration or deceleration. Okay, negative acceleration means your acceleration is in opposite direction to your motion. For example, you're moving in this direction with a velocity v, but your acceleration is in the opposite direction, so that is negative acceleration, right? The word deceleration means that your acceleration is decreasing. Acceleration is decreasing, right? So that is what those two words mean. They are interconnected, but they have some difference. Okay, so negative acceleration means acceleration is opposite direction. Deceleration means acceleration is decreasing. Okay, so when velocity decreases every second, we can say that either there is a negative acceleration or there is deceleration. Along with that, again, we saw speed, velocity, displacement, and distance. And along with this, we also saw what is the difference between uniform acceleration and non-uniform acceleration. The velocity of a body changes at a constant rate in a given time interval, whereas in the non-uniform, the velocity of a body does not change at a constant rate in a given interval. Right here, in a given interval, it is changing at constant rate at 10 per second. Right, so it's changing at 10 per second, but non-uniform, it is not going to change 10 per second. Okay, so examples of non-uniform motion can be rocket being launched in the air. This is a diagram for Save My Exams, but it's a very good diagram to help you understand that non-uniform motion exists. For example, we have rocket launching. You see, the velocity of rocket will increase by a lot every second. It's not going to be constant. So this is an example of non-uniform motion. Along with this, we can say someone stopping a car. That is another example of non-uniform motion, right? So these are some examples of non-uniform motion or non-uniform acceleration. Now finally, the part that I want to discuss on is the one-dimensional motion. And these are the equations that we derived in the previous class. and these are the heart of kinematics. So there are some conditions to use this equation. They must be in the same direction, and the acceleration a must be constant. Now this is not I just thought of it in 2 seconds. This is exam oriented rules, which means these two conditions will help you answer the exam conditions and exam style questions. Okay, so these are very important rules. You must tick both of them in order to answer the question. And remember the SUVAT method, SUVAT. You fill in whatever you have, right? And there's always going to be one useless one, so you take that out and you will have the variables that you need, and you select an equation. Okay, you select an equation. Alright, then the other thing we saw is if a ball is thrown upwards, its velocity will decrease to 0 and its u will be maximum, right? Its u will be maximum. So you see its velocity is upward and its acceleration is downward, right? Opposite direction means sign is opposite, so I take acceleration as negative. Then let's say we drop a ball from the top to the bottom. We take u as 0 and v as maximum, right? And if the velocity and the acceleration is same direction, we take acceleration as positive. Okay, be careful with this sign. Opposite direction means opposite sign, same direction same sign, right? This sign assignment, this you can assign this sign, right? I have assigned down as negative and up as positive. You can flip it, that's up to you. Okay, in physics it's up to you whichever direction you want to take, positive and negative. Mostly we take acceleration if our body is moving upwards, right? We take up as positive, and if acceleration is down, we take that as negative. And if they're in the same direction, to make things easier, we're going to take down as positive, so both of them become positive. Okay, so it's honestly up to you. Then we see another example. This is a combination of both. So here u is 0, here v is max, right? Then here u is max, u is 0, v is max, u is max, then v is 0, and then v is max. Okay, and do you see this height decreasing? Why does the height decrease? Is because there is energy losses. Okay, because of energy losses, thermal energy being lost, sound energy, elastic energy, because of all of these energy, the height decreases. Okay, another thing we saw was inclined planes. We saw that this angle is theta, this is 90 minus theta, and this is 90, right? Because 180 is equals to 90 plus theta plus question mark. Let's say this thing is question mark, right? So if you move it to the other side, you will get 180 minus 90 minus theta is equals to question mark. So that's going to be 90 minus theta is equals to question mark. So this angle becomes 90 minus theta. Now you see this entire thing. You see this is the vertical and the horizontal, the vertical and the horizontal. So you see this angle here is 90 degree, right? Which means 90 minus theta plus this is question mark. Let's say question mark is equals to 90, right? So I want to get rid of this minus 90, so I will do 90 minus theta plus theta is going to be 90 degree. So 90 is equals to 90. Do you see that? If this is not theta, then even though this is 90 degree, it's supposed to be 90 degree, it won't be 90 degree. So this angle must be theta, otherwise it just won't make sense, because this is supposed to be 90. Okay, right? So you don't have to memorize this or anything. It's just extra stuff, okay, for you to understand. So what you have to understand is we draw a dotted line like this. It's a normal line. Normal line is perpendicular to this surface. Normal means perpendicular to the surface, 90 degree angle with the surface, and this angle theta is same as this angle theta over here. Okay, and remember the side with the theta is g cos theta, and the side that doesn't have the theta is g sin theta, and we will use this a lot. g sine theta. Okay, how do we get this? Is if you see here, say this is beta y and this is x, this is g, this is theta, then I know sine theta is equals to opposite over hypotenuse, so y over g. So I will get sine theta g is equals to y, so g sine theta is y. Okay, then if you see here, cos theta ah, that's x over g, so cos theta g is equals to x, which you can also add as g cos theta is equals to, my bad, that's supposed to be x, is equals to x. So this is just an example of how we actually do it here, right? So this here is different example, but essentially we use trigonometry to get this, right? But the simple rule is the one with theta is cos, the other is sine theta. That's the best rule to understand, because you won't be doing this in exam. This is just to show you how it's done, right? But in exam, memorize this. This will help you do things quicker because time is important. Okay, so hope you keep these things in mind. If you want, you can pause it, you can go through this. I'll just go through them slowly. Here you go. Okay, just look at them, memorize them, understand them, and we will solve some questions. Okay, so question number 14 will be solved by you. You can solve it, you can give it a try, guys. Question number 13, of course, I'm gonna solve. So an airliner must reach a speed of 110 meter per second to take off if the length of the track available is 2.4 kilometer. Okay, and again look at the word here, the aircraft accelerates uniformly. Why is it uniformly? Is because our acceleration must be constant. If our acceleration is not constant, our equations of motion will deteriorate. Okay, if you want to know what that means, I explained it in class. You put a as 0 in all of these equations, put a as 0, because acceleration, if acceleration is not constant, then what's going to happen is your a will change, so all your equations will deteriorate. Okay, don't put a as 0, the equations will deteriorate, because then you would have to differentiate to find the acceleration, right? And that's outside of the scope of the specification. Okay, so you always take the example of uniform motion. Okay, because if your acceleration is constant, that's good, right? If your acceleration becomes 0, if your acceleration is not constant, then your equation of motions will become will deteriorate. Okay, for example, if you take acceleration as 0, you try it out, you will get only one equation, which is s is equals to ut. If you see the acceleration is not constant, then you can use no equation, because you would have to take acceleration for every single second, and you can't do that, right? That would take you at least 1 hour to find the acceleration, so we don't do that. Okay, so that is why we need the condition of it to be in uniform motion, uniform acceleration. Okay, anyways, so it must reach a final velocity v of 100 meter per second, and its u is equals to 0. So what is acceleration? Okay, so again s is equals to s u v a t. First do that. Okay, let's do this first. So you know s is 2.4 times 10 to the power of 3, u is 0, v is 110 meter per second, a we don't know, time we don't know, and this we have to find out. Okay, so you can go and you can check the equation. I recommend you take a picture of this, or if you have the equations already, that's well and good. Okay, so we'll have v square is equals to u square plus 2as. Now what's gonna happen is your u square will cancel out, because u is 0. Then you will have 110 square is equals to 2 times 2.4 times 10 to the power of 3 a. So let's calculate a. You can pause and try each question as well. That's going to give me 2.52 meter per second square. Remember, in exam, write your answer to 2SF or 3SF. Otherwise, marks will be deducted. Okay. Alright. Okay, next question. Again, question 15, dear student, is for you. अभी हम जो next question करेंगे, that is cricket ball question. So a cricket ball is thrown vertically upwards with a velocity of 15 meter per second. Okay. Now you will say, sir, why are you drawing everything? Remember, without drawing you can solve no question. Without a bit of animation you can solve no question. Draw it out, you'll understand it better and read it carefully. Okay. Even if you draw it out and get it wrong, that's okay. Just keep doing that, you'll master it. Okay. Anyways, so 15 meter per second. What is its velocity when it first passes through a point of 8 meters above the hand? So this is the hand, let's say, right? 8 meters above the hand. So distance of 8 meters. And we know acceleration is negative 9.81 meter per second square. Right? So where did you get this from? Remember this question? You throw something up. Acceleration is negative 9.81. U is max. Here V is not 0 because the question says that the velocity is not 0. Okay, if you see here, the question says to us, we're not sure if V is 0. They have given us U, but as for V, give me a second, why is it not working? So will we say V is 0? Well, we can't really say V is 0 because the question doesn't give us enough information to say if V is 0 or not at this point. Okay, but we do know it will reach 8 meters above and we will find the velocity, right? So let's see if V is even 0 or not. We actually have to find that velocity. Okay, so what's gonna happen is SUVAT again. Your S is 8, your U is 15, your is negative 9.81, your V is question mark, this is question mark. We don't need this, so again same equation, V square is equals to U square plus 2AS. That's gonna give me V is equals to 15 square plus 2 negative 9.81, S is 8, and then square root this. Let's see what we get. So you get an answer of 8.24, 8 meter per second. Get that to 8.25 meter per second. That's the final answer to that. Now please do try question 14, and now let's move on to past paper questions. Okay, so here's a past paper question. It says a ball is thrown vertically upwards. You can pause and do it. Which row of the table correctly describes the magnitude of initial acceleration of the ball and the magnitude of acceleration when it's at max height? So we have a ball and it's thrown vertically upwards and then it comes back down, right? So they say, what is the acceleration value here? What is the acceleration value here? And I assume, give me a second, they have taken down as positive because we have positive values, or they actually, yeah, okay, they don't care about positive or the negative sign. You know why they don't? Because it says magnitude. Whenever it says magnitude, we don't care about the positive or negative sign. Okay, so either acceleration could be negative or positive. I'm not sure what convention they have taken it, right? But they say what happens to the value of acceleration. Okay, now I'll give you example. Okay, give example. Say you are playing a game, right? Let's say we have a ball. Okay, badminton, for example. I have a friend who loves badminton. Okay, when you throw the ball at this point, and at this point, right, at every single point, it will be experiencing weight, right? mg. Is there ever a point it does not experience this g force? There is no point. Every point that you throw the ball, it will experience a gravitational force, right? So every single time, every single moment, there is gravitational force because you are on earth. If you are not on earth, there will be no gravitational force, right? Now this question is made for you that if you throw the ball up, at this point also you have weight acting, this point also weight acting, at this point also weight acting. The g is always acting. The gravitational field strength is always acting no matter what moment. The v is 0, the v becomes 0, I agree with that, but a is always the same, right? You can stop and gravity will still act on you. Sir, how do you know it acts? Because it falls down then as well. right? That's proof that gravity is acting. So A is always 9.81. So the answer is initial acceleration, and at max height the acceleration is 9.81, 9.81. That isn't changing at all. Okay, so answer is C. Okay, next question. An object accelerates from a rest down to accelerates from rest down a frictionless slope. Why is it frictionless? Is so that our acceleration can be constant. Remember that. Frictionless. When friction is not there, acceleration is constant. The object moves a distance of 20 meters at an angle 27 degrees to horizontal. What gives the final velocity? So again, SUVAT. S is 20. This is 0. This we have to find. And remember remember the conditions. Two conditions beta. One, they all must be in same direction. And one, acceleration must be constant. Now this condition is met, right? But if you take the accelerations as 9.81, right? Distance is in this direction, velocity in this direction, right? Everything is in this direction. Acceleration is not in this direction. You already know how to do this. This angle, give me a second, right? So this must be in the same direction. So this is gravitational force, the gravitational strength, which is 9.81. This angle is also 23. Sir, how do we note this? This thing you have to memorize, and I already told you have to memorize it from here. Okay, I already explained that. If you don't understand it, go back in the video, watch it again. Okay, so this becomes 9.81 sine 23, and this becomes 9.81 cos 23. Beta, the one that has the angle is the one that is cos. The one that doesn't have the angle is not the cos, it's a sine. Which means this is 9.81 sine 23, because it is parallel with your, it is in the same direction as your distance and your your velocity. Okay, yeah. So all your answers with cos is wrong, because we are taking acceleration in terms of sine. Then what you do, you find a formula which is v square is equals to u square plus 2as. Now they have told you u is 0, so you cancel this out. You have to find v is equal to square root 2 times 9.81 sine 23 times distance as 20. The correct option is C. Okay, next question. Now this is another interesting question. So in this question, we have to find the maximum height after popping. Okay, so you can take your time, you can attempt the question, and then I'll solve it. So there are two ways to do this question. One, they have given you a scale, so you can actually take your ruler and you can measure this out, right? That's totally fine. You can easily get those 2 marks. But if you can't do that, then you will have to take the longer way. Now personally, if it were me, I would have done this with a ruler. It would be way easier. You would get an answer of 3.37 centimeter for this one, right? So that would be much better. But if you do like to go the longer way, go ahead. And personally, I'm doing this question with equations only for your practice. Okay, in exam, do this with the ruler. But just because we are going to do some practice on the equations, because there are very less questions on this. So that's why I'm taking this question for that as well. Okay, so again, first step always SUVAT. Okay, so this is a bit longer way, but we'll try it. Okay, so we have to find this. We know that U is max here and V is 0, and it's moving up, right? Give me a second, I'm changing my color. So this is moving up, okay, and the gravity is acting down. So what I'm going to do, I'm going to take gravity as negative 9.81. So negative 9.81, then V is 0 at the top. Time is 83 times 10 to the raised power of negative 3. U I don't know, right? So I know that I can use an equation. Now first of all, let's find U, okay, because to find S, I can use S is equals to UT plus half AT square. Okay, So I need to find u for this equation. So the equation I can use is v is equals to u plus at. So I know u is 0 is equals to u plus negative 9.81 times 83 times 10 to the power of 3. If I move this to the other side, this negative sign will become positive. So it will become 8.1 times 83 times 10 to the power of 3, right? Basically what happens, because of this negative sign, this entire expression becomes negative, right? So when I move it there, it becomes positive, okay? So that's going to be u, okay? So let's find u out. So u is beta 83 times, okay. This is negative, by the way, my bad. Negative, okay. So it's going to be 0.814 meter per second, right? So next what you got to do is you got to find max height, okay? Oh, we've done part 2 itself here, right? We have done part 2 itself. Nice. Okay, so next you gotta find the maximum height. That's gonna be s is equals to 0.814 times 83 times 10 to the power of negative 3 plus half negative 9.81 at 83 times 10 to the power of negative 3 square is equals to, that's gonna give me answer of White House 0.0337. If I times that by 100, I'm going to get 3.37 centimeters. Okay, and then with this you can find the initial speed as well, which we already have actually found, right? So we've kind of done this question in a very weird way, right? That's why I was saying that at Excel they most likely want you to use ruler first and find the distance, and then they want you to use s is equals to ut plus half at square to find the initial speed, which we already have. So we went kind of like a pseudo way, a very weird way, and did this question. But yeah, it gives us good practice on how to use equation of motion, especially this equation of motion not many people use. So this is one way you can do this question, and you can get both parts, right? Yeah, so if you get stuck here or something like that, then please do you be careful with the equation of motions and how you have to use them, right? And yeah, that's how you do this part. I put this question again because there are very less questions to practice. Okay, so let's do the next question now. Okay, so next question, again you can try this yourself again and let's see how it goes. Okay, right, so here it says a child starts from rest at the top of the slide and moves down the slide. Resistive forces acting on the slide can be ignored. Okay, explain why the equation of motions cannot be used to determine the maximum speed of the child. You should consider the shape. Okay, so you see this shape here, right? Now everyone went to the slides, right? So basically you see what happens is as you're moving on this slide, right? So let's say you're gonna be kind of like, okay, you're here, right? You're gonna walk up the stairs, you're gonna get here, right? As you're here, you're gonna start to slide down, right? So your speed will start to decrease here, right? Okay, and then suddenly your speed will increase and you fall down, right? That's usually how it works. So you fall down quickly, right? So at position A, let's say, and then position B and position C. So at A you're kind of slow, okay. At B you slow down, right, to rest, almost rest, almost rest, and then at C you go very fast down, right? Do you think the acceleration will be constant? Because you know that for using the equation of motion, acceleration must be constant, right? So first you write the gradient of the slope is changing. This would mean that the slope, you see the gradient of the slope means the change in y and change in x, right? So the distance traveled every second, the speed is changing. At first it's slow, then it's fast, then it's very fast. So we say the gradient of the slope, the steepness of the slope, basically the steepness. You see it's steeper here, it's less steep here. So the steepness, right, that's the gradient. So the gradient or the steepness, right, the steepness is changing, right? Because of that, the acceleration is not constant, right? And to use the equation of motion, your acceleration must be constant, hence why we cannot use them. Okay, so that's the answer to question number 3. Okay, right. Now in some papers also, they will sometimes maybe say that there is resistive forces acting and stuff like that, right? So you can also say, this time they've ignored it, maybe they'll say, okay, resistive forces are there, or maybe they won't even talk about resistive forces, they will just say the boy is falling down, tell if we can use or not, right? So at that time maybe you can use even resistive forces as an answer, but here we can't because they have ignored it. Okay, all right. So here is another question, and this is a difficult question, it's not an easy question, but I'll try my best to make sure that you understand it in the easiest way possible. Okay, so here's part 1, you can try it yourself, pause, take your time, do it. Okay, all right, and then here is the part B. Okay, I recommend you go through quadratic equations and stuff, because part B does involve quadratic equation, so go through that as well. Okay, all right, so that's that. Let's do the question. Okay, so we can see that car A, right, is 9 meters ahead of car B. Okay, and car A is traveling at a constant velocity. Remember, when the velocity is constant, that means velocity is not changing, so acceleration is 0, right? So when acceleration becomes 0, there's only one equation you can use, s is equals to ut. Okay, so this has a constant velocity of 93 meter per second. Okay, the next thing beta you have to be careful with is, at an instant car B has a velocity of 93 also, so this also has 93 meter per second, and car B is accelerating with a constant, which means you can use the equation of motion, constant acceleration of 14 meter per second square. Okay, right, so this is the information we have been given. Then they say, show that car A and B are side by side after a time of about 1.1 seconds. So we have to find this time, right? So let's do SUVAT. This is for car A, this is for car B. Okay, so carefully read the question, I'll put the values in. So this is the distance traveled by car A. Okay, I will talk about the distance traveled by car B in just a second. Okay, I will let it as distance traveled by car B. Initial velocity is 93t for both of them. Final, I don't care about that. Acceleration here is 0, here is 14t, and time I have to find, right? So show that the time they are side by side is 1.1. So time is what you have to find. So t and t, right? Let's put that as t and t, right? So both of them, right? Let's say they start moving, right? So here's car, this car, and here's this car, right? I hope I can erase this stuff up here, right? Let's erase this. Okay, so let's say this car starts moving. Now you see this car is accelerating, right? Let's say this is this car, right? This is car A, car B, right? So you see this car is here, this car is here, right? So this car starts moving. Now you see this car is traveling at constant velocity, so it's gonna be moving like just constant, right? And this car is accelerating, so it's gonna start to catch up, and they're gonna be at some point face to face with each other, right? So they're going to be at face to face with each other. What is that time when they'll be face to face with each other, right? Okay, so you see at some point they'll be at face to face with each other, right? And you see the distance traveled by SA, right, will be, so this will be the distance traveled by car A, and there will be a distance traveled by car B. Okay, right, very clear. Okay, I'm going a little slow. Okay, there will be a distance that the car A traveled to reach this point, and there is a distance that car B traveled to reach this point. Okay, all right, so they both traveled a distance to get to this point, right? Now you see car B always traveled 9 more distance than car A. Sir, why did car B travel 9 more distance? Is because it had to get rid of this 9 meters, because there was a 9 meters difference, right? So car B had to travel 9 more meters than car A, right? So car B had to travel 9 more meters than car A did. Okay, to finish this 9 meters distance off and come right next to it, the car B had to travel 9 more. So car B traveled 9 more meters distance than car A. At this point, right, whatever their distance is, car B traveled 9 more than car A, because it had to finish this 9 meters distance off. Okay, so then I can say, right, so that's one way to understand it. If you understood it here, then the next part of the video you can just skip it. Okay, right, but remember this equation: SB is equals to SA plus 9. Okay, for people who are a little bit confused. Okay, so can I say this is 0, this is 0 meters, this is distance over time graph. So this is car BA. So this is car A, starts from 9 meters ahead. So it starts from 9 and it's gonna travel at constant velocity, right? So this is it traveling. Now car B starts from 0. You see car B starting from 0 and it's gonna accelerate. So a graph of acceleration looks like this, and they're gonna meet at a time t. Okay, right? You see the time t? Okay, give me a second, right? So you see this is a distance traveled by car S, this is a distance traveled by car B, and this is 9 meters, right? And this entire thing is the distance traveled by car, or maybe my bad, this is the distance traveled by car A. This is 9 meters and this is the distance traveled by car B. See that? So car B traveled this much distance, whereas car A only traveled this distance, right? So look, 9 meters more always. You see that? SB is SA plus 9, right? SB is SA plus 9. Okay, so then you get this equation between them. Okay, so that's what you have to write. Okay, so the distance traveled by SB is always 9 more than SA. Okay, so you have to find that distance. Okay, so now what you have to do is you have to put, so the only equation you can use with this is UT plus half AT square is equals to UT plus half AT square plus 9. This becomes 93T plus half 14T square plus 14T plus, now this is 0, remember this is 0. For car A, its acceleration is 0, so this entire thing becomes 0. So cancelled out, plus 9, right? My bad, this was supposed to be 93T. Okay, then 93T cancel out, so you get half 14T square is equals to 9. That brings you to 2 multiplied to the other side, 18 over 14 square root is equals to T. That's gonna give you 18 over square root of 14. So that gives you 1.13 second, which is approximately 1.1 second. Okay, so hope you understood this question. This was a very good question and a tricky question, but if you just understand this part, right, you see, understand this part, you get the entire question. Okay, so SB travels 9 more than SA. So the distance traveled by SB is always 9 more than SA, right? Okay, at the instant shown, okay, let's just copy this diagram down. This is the last question, by the way. There is no more question after this. Okay, the distance, let me just bring it down. Let's bring it here. Okay, you just skip to the part where I'm going to do the question. Okay, So here we have this. At the instance shown, car A is 100 meters from the finish line. So car A is 100 meters from the finish line. Deduce whether car A reaches the line first before car B. So we have to find the time, right, that it takes for car A to travel 100 meters and win the race, right? So I can say 100. So again, the formula I'll use is S equals to ut plus half at square. So car A has to travel 100 meters. Okay, give me a second. So that's going to give me a t value of 1.097 seconds. That's the time value for car A. For car B, we can use the same formula, but you see car B has to travel 9 more than car A. Car B has to travel 9 more than car A, so 109 is equals to 93t plus 7. Now I didn't put half 14, right, because at half 14 is a 7t square, right? Okay, so half of 14 is 17, so I just put 7 here. Okay, that's going to give me 17t square plus 93 t minus 109 is equal to 0. Take your quadratic formula and plug it in. Okay, so give me a second, let me just take my calculator. Okay, that's gonna give you, so that's minus 93 plus minus square root 93 square minus 4ac divided by 2a. Now I'm not gonna use my calculator. You can simply press your mode button. After that, you press your mode, press 5. Give me a second. Mode 5. Then you press 3, and then you put in the 793 and negative 109. 793 negative 109. Press equals to. You get your time as 1.0836 seconds and negative this seconds. This is seconds. This is seconds. Okay, seconds. You reject this time. Negative time cannot exist. So time taken by car B is 1.084 seconds. So you see the time taken by car A, time taken by car B. So time taken by car A is less than time taken by car B. So car B takes more time than car A. So car A will finish first. Okay, right, because something, so this car takes less time, so it's going to reach quicker. This car takes more time, so it's going to reach after car A. Okay, so this conclusion part is important. It comes for, there's a mark for this as well, and that's the end of this revision session. Okay, I recommend watching this video in 1.5x.